Okay, now I'm going to show you how to complete this task on the 4.3 MATLAB, transforming the graph of y equals x squared using technology. Okay, so this time not using TR-83 calculator, instead we use Geogebra, the application. You can download it free from the website. Okay, so let's first of all we need to graph the y equals x squared. So you come here, so under the input bar, so you just type in x squared. Now you type in this way, x squared, without the y equal. So because they assume your function always start with y equal, so just enter. So you're gonna see you have a function like this. Okay, and then you can, if you don't like the position, you can just drag around. Okay, you can even change the scale, right? So now let's keep about the same ratio for x and y axis. Okay, now you can easily tell this is the graph. It has opening up vertex at 0, 0. And it easily can tell because when x equals 0, y equals 0. And then the axis of symmetry is the y-axis. If you write the equation, it should be x equals 0. Okay, and then let's pick another function and take a look at it. So let's see if we try to graph the y equals negative x squared. Okay, if we do this, we can come back here and simply type equals negative 7x squared and enter. Oh, sorry. So I am not supposed to put an equal sign. Enter. Here you go. I get a different function. And this function, you can tell, the opening is down, right? The opening is down. And move a little bit over here, so I can fill the information right here. So for this one, I should have the negative coefficient of the x squared. You should have get an opening down, because for any x value after you square it, you multiply negative 7, you always get a negative y. So that's why all the graph is all under the x-axis. So the opening is down. The vertex looks like it's 0, 0. We're gonna prove that later on using one of the function in this application. So the axis of symmetry looks like still x equal 0. Is this graph looks like a congruent to the y equals x squared? No, it's not. It looks like it's compressed horizontally. It looks like horizontally compressed. Now, interesting enough, you can always look at a different way. You can also, it's like a vertically stretched. Okay. Of course, it's opening, because opening down looks like it's flipped down from the original position. Okay, now let's use to confirm that it has 0, 0 as a vertex. Now look at this graph. So we try to figure out the vertex. Now actually, instead of vertex, we're trying to figure out what's the point of maximum y. So we can type in max, and it automatically give you a list of functions. So I pick this one, and then basically you need to decide which function you try to locate to the maximum point. So you can see we're gonna find the maximum point for the gx. So we simply press the keyboard G, and then use the cursor move to the start value. Start value, as long as we know the vertex is around 0, if we're not sure, so we can just simply type in -1 as a starting point, and then use right arrow, and then +1 for the ending value. So then just press enter. So you can see there's a point plotted on the graph, and then the coordinate of this point is already shown on the left side. So the point A has a coordinate of 0, 0. Okay, so of course, if you are given a different function to find out the maximum or minimum depending on the opening, right? So we can try a different one quickly. See if we have a function called x, let's see, 2x squared minus 3x minus 1, for example. Here you go, we get this kind of function. This function is going to opening up. It's called hx. So let's find out the vertex. This time we need to find out the minimum, because opening up, so the vertex is actually the minimum point. And again, we choose this one, and then the function is h. So typing h, arrow, and input the starting x value. Now looks like he just estimates, right? So the vertex looks like it's close to 1, so we can just type in 0. That's pretty safe. And then we type in 2. So enter. So we got the point B as the vertex. So the vertex is 0.75 for x, -2.13 for y. So that's the way to find out minimum or maximum. Also, if it's a quadratic function, so you're finding the vertex.